Hello students, welcome to Distinction Learning platform, and on this platform you'll find revisions, explanation to difficult topics, quizzes, tests, a lot of stuff. So before we begin our lessons, make sure that you subscribe so that you can be updated with our upcoming videos. To make the story short, let us begin. In this video, we're talking about overview to both pharmacokinetics and pharmacodynamics. Why talking about the overview? Because if you have an overview of something, if you the moment to begin studying about something, you know the end product, okay? You know that okay, on pharmacokinetics I'll be expecting this and that. On pharmacodynamics I'll be expecting this and that. So that's why it is very important to know the overview, because if you don't know the overview, you start studying just like that, what will happen? You will start failing to study, okay, because you don't know what the end product is all about, okay? So that's why it's very important to know about what the overview, okay? And don't worry, in other videos we'll start talking about what pharmacokinetics individually, as well as what pharmacodynamics individually, so that now we can fully understand what pharmacokinetics is all about, okay? Now let's start with pharmacokinetics. What is pharmacokinetics, okay? So pharmacokinetics basically it talks about the processes that talks about what deposition of drugs, and including what it includes absorption. What else? It includes distribution of drugs. It includes metabolism of drugs, and what else? It includes what the excretion of drugs. So that is all about what the pharmacokinetics. So what are we saying about pharmacokinetics? So we're saying it's the process. So let's just say it's the process of deposition of drugs, okay? It's the process of what? Deposition of drugs, including what? Through what? Through what type of processes? Through, okay, the first one we talked about what? Absorption. Okay, what is the second one? The second one I said distribution. Okay, what is the third one? Metabolism. Very important. And the last one is what? And excretion. Okay, so these processes are very important when it comes to what pharmacokinetics, because if you look at absorption, we'll come and talk about it individually, because there are a lot of things that you need to understand about what absorption, distribution, metabolism, and what excretion. But how can you remember that? Because if you remember these important processes, they are going to help you to differentiate with what pharmacodynamics, okay? So the only thing that you can use is this mnemonic, which is ADME. Okay. ADME stands for what? A stands for absorption, D stands for distribution, M stands for metabolism, E stands for what? Excretion. This is all about what? Pharmacokinetics, which is what? Very simple. But I found out to say a lot of students they find it difficult to understand about more pharmacokinetics. It's very difficult to understand about what pharmacokinetics. It is the main reason is that you didn't understand about the introduction to what pharmacokinetics. So you don't need to start mastering concept under what pharmacokinetics. So first of all, we have understood that pharmacokinetics involves what type of processes: absorption, distribution, metabolism, and what excretion. But if you want to remember, you can use ADME. Okay. ADME is the correct what is a mnemonic that you can use to remember about all the processes that will happen under pharmacokinetics. And what are the important things about pharmacokinetics? What are you really supposed to know about pharmacokinetics? Okay, we'll talk about this. So the very important thing that we need to know about pharmacokinetics is what? Just three important aspects. The first one is what? The rate and extent. Okay, so the first one is what? Rate and what? Extent of what? Absorption and what? Distribution of a drug. So absorption and what? Let's say absorption, so A and what? D, which is A and D. Absorption and the distribution of what? Drugs. That is the first important thing that you need to understand, because rate is very, very important when it comes to what absorption. You don't know what time the drug will start what happening, or producing its effect, okay, or how much drug is going to be found in the what concentration there, or in the plasma there. You don't know. So it's very, very important to know the rate and extent at which the drug is going to be what absorbed and what distributed. Very, very important. These are the things that we're going to be talking about, okay, in the next video. What else apart from that? As well as we're going to say, okay, again, rate, very important. Rate and what? Pathways. Pathways involving what? Metabolism. Metabolism. It is, let's say, we know that M is metabolism. Okay? M, metabolism, and what? Excretion. So rate and pathways involving what? Metabolism, because we start talking about metabolism, the phase 1 and phase 2 type of metabolism that will happen in the liver. So we'll come and talk about them. Very, very important to know those pathways, because you're going to be assessed, and it's very, very important part, because it will tell you also the dosage of the drug that you're going to give a patient. Okay, very, very important. That is the other thing. And the other thing is this one. So the last one is what? Time. Okay, and what? Let's say plasma concentration. C stands for concentration. Plasma concentration of what? Of drugs. So the relationship between the time that you gave the drug and the plasma concentration of the drug that you gave the same patient, then it will help you to also understand something, the side effect of the drug that you gave that patient. So generally, what we're talking about is this, okay? Understand something. So the most important thing that we need to be talking about under pharmacokinetics, including all these processes that we're talking about, is what? The first one is what? Rate and extent of what? Of absorption and distribution of what? Drugs. We'll talk about that. Okay, what are the things, what are the factors that will affect the rate of absorption, the rate of distribution? Very, very important. Okay, then the other one is what? The rate at which the drug is going to be what? It's going to be excreted or metabolized. Okay, very, very important, because if you know the time is going to be metabolized, you know that okay, this is the right time to give another drug or to prescribe another drug. Okay, very important. And also the pathways, okay, because these pathways, metabolism that happen in the liver, it is different from so like individuals, they are going to have what? Different metabolism in the liver. No wonder you find that to say the responses of drugs to different individuals, it will differ, because of they are going to have different metabolism or metabolic reaction that will happen in the liver. Okay, you need to understand that. We'll come and understand in the next video. Okay, then the last one is what? Time and plasma concentration. Okay, you need, because if you give a drug, you expect what? The plasma concentration of that drug to be what? Increasing like that, because you are given either any route, okay, either oral route or PO, either intravenous or maybe intramuscular. We'll come and talk about the route of administration, okay? Either route, then it will tell you about what the plasma concentration, but also the time taken to reach that plasma concentration is also important. No wonder time plus and plasma concentration, they are very, very important aspect when it comes to what? Comparing the two. Okay, to tell you also when to give the dosage of the drug, and it's going to tell you that okay, the drug is being eliminated from the what? From the plasma. Okay, because of those things. Very, very important thing. Okay, now the question that you can ask yourself is that why am I troubling with all these things? Okay, all these pharmacokinetic processes. Why am I troubling with that? Why? So the question that I'm asking is what? Why are we learning about pharmacokinetics? You need to know why. Because if you know the reason why you are doing something, it will give you, also the brain is going to be interested in knowing more. Okay? So what's the main reason why we're talking about that? The rate, everything like that. Why? Okay? The reason why is that it helps doctors or clinicians and health care. Then it will help us to what? In the dosage. So we call it a rational dosage. Okay, so it will tell us what? Dosage, the amount of dose that you're going to give what? A certain what? Patient So it talks about what the amount, the ratio what dosage regimen. Okay, it will tell about that. It's because of what pharmacokinetics. How do you know that? Okay, this drug I'm going to give about what 2 milligrams of that drug to this patient. How do you know that? It's because of what pharmacokinetics. So it's a beautiful topic. You need to understand it. Okay. So dosage, it will tell us about that. The other important thing that I talked about, what was that? We said inter-individual variation. So what is the other important aspect? It will tell us about what inter-individual what variation. Inter-individual what variation. Why? Why inter-individual variation? Because I said to say different people, they are going to respond to a drug in a different way. The same for me, they give maybe those like antihypertensive drugs they give me, I'm going to respond differently. Maybe I'm going to respond faster, or maybe I'm going to respond slower. But how are we going to know that okay, this patient is responding faster to this drug, or this patient is excreting this drug faster? How? It's because of what pharmacokinetics. It will tell you. Okay, very important concept. Now let's go deeper so that it's just an overview. So let's start with what? Let's talk about the absorption. We understand more. Let's talk about the distribution, metabolism, and what excretion. Let's talk about that. So let's start with absorption A. So what is absorption? It is A. What is absorption? Absorption basically is a process that's going to tell us how the drug is going to enter into the the blood, like that. Okay, to pass through the different membranes and enter into the bloodstream, like that. That is all about absorption. Okay, so what are we saying? So we are saying absorption just tell us about how the drug enter into the body. So how the drug entering into the into the body. Basically, we're talking about the blood vessels. But there is an important concept that you need to understand here is what? Except if you give someone a drug IV, except IV administration. Let me just say admin. Okay? Except what? IV administration. So IV administration is not under what? Absorption. That is an exception, because if you give IV basically stands for what? Intravenous type of administration. You give a needle. You get what a needle like that, okay? Then you insert a drug direct into the blood vessels. If you insert a drug direct into the blood vessel, it's not going to undergo the process of absorption, because you're just putting it direct into the blood vessel. No wonder absorption is excluding what? IV administration. That is a very important concept that you need to understand. Okay, so that's what about the absorption. So what are we saying? Using this diagram, let's say you give a drug enrolled. Okay, maybe let's just say you give a drug PO. You're just talking about oral administration. Okay, you give a drug orally. Okay, they drink either paracetamol, whatever the penicillin, whatever the drug it is. Okay, anything you give it like PO. Although there are other way you can give it. Okay, you can give it subcutaneous. You can give it subcutaneous. You can give it intramuscular as well. You can give it sublingual. You can give it in those types of routes. Very important. Now let's say you give like that. Okay, this is a drug which is here. Okay, so this is PO. Okay, let's say it is in the gastrointestinal tract. So what's going to happen to this drug? This drug which is here, okay, it's going to be absorbed through these like this is the epithelial lining of the gastrointestinal tract. Okay, these cells are going to start absorbing this according to maybe the type of the drug that is there. If it is lipid soluble, water soluble, whatever, we'll talk about the pharmacokinetics and absorption in details. Okay, it's going to be taken up by these cells and put into the blood stream. So this is a blood vessel. Okay, that is a blood vessel. That's all about absorption. As you can see, this drug is passing through different membranes. So absorption has to include a drug passing through different membranes after administration. Okay, after you give a drug, then it starts to, if it is passing through different cell membranes or epithelial lines in there, okay, then that is what we call absorption. So come and talk about it in more details. That's what we call absorption. Let's go to another concept, D. So what did we say about D? D is what we call distribution. Okay, D is what we call distribution. Now, what is distribution? Now, distribution talks about what? How the drug is moving around the body. It's just moving like that. Okay, it is moving from one place to another, but it doesn't end from there. What does it do? Also enter into the what? Interstitial space where the cells are. So basically they need to pass as well the cell membranes of the what? Different what? The endothelial lining of the blood vessels there. Okay. After that they pass there, then they will go to the what? To the cell. Let us look at what? The illustration, that whatever I'm talking about. Listen, after this after administration, okay, I mean after absorption like that, the drug is already in the what? In the blood vessel there. Then if it is moving within the blood vessel, okay, it is moving within the blood vessel, moving around like that. That is what we call distribution. But I said it doesn't end from there. This drug will start now. For it to have its effect, it has to pass through the what? The lining, the endothelial lining of those blood vessels, and enter into what? The interstitial space of where the cells can be found. These are the cells. They are in the interstitial what? Interstitial space. Okay. This drug now will enter here into this interstitial space. It will go there. Okay. If it goes there, then it has to start now a bind into these cells. If the moment it binds now, then we'll start talking about what? Pharmacodynamics. Now distribution just ends from where the drug moving around in the blood vessels and going out of the what? Blood vessels, passing through different what? Cell membranes, then going into the what? Interstitial space. That's where distribution ends from. Okay, so what are we saying? So what are we saying about this? We're just saying drugs moving around in the body. Okay, basically we're saying blood what? Vessels. Okay, and what else? What did I say? And also entering what? Tissues. How do they enter tissues? By what? Passing membranes as well. Okay, membranes. So like the capillary wall there, okay, they pass to the capillary walls. Okay, we'll talk about the distribution in more detail. So just know that distribution just talks about the drugs moving around the what? The body and entering the what? The tissues. Where the tissues are. Well, can you find the tissues? In the interstitial spaces. Okay, that's where you can find tissues. So that's about what? Drug what? Distribution. What else? Let's go to M. What is M? M is what? Metabolism, okay, or metabolic reactions, okay. So metabolism basically we talk about phase 1, where you are making the drug to become more active or more water soluble, okay, and where you are making the drug to become what? Lipid soluble, like that, okay. Basically we talk about that. Okay, now the question is, where is that metabolism happening and why is it happening? Okay, so metabolism, most of the time the major organ that like shows metabolism is what? The liver. Very, very important. Okay, the liver, but not only the liver, also if you look at the skin also can show what? Metabolism. What else? Also the kidneys. Okay, also the kidneys can show what? Metabolism. What else? Also the gut. The GIT there. GIT also can cause what? Can show what? Metabolism. Very, very important. But the major one is what? The liver. This one I'm emphasizing on this one. Make sure that you know that okay, this one is a major. Okay, that's why metabolism can happen. And remember that metabolism can have what? Different phases. Phase 1, phase 2, which would come and talk about them in future. Now, the question that I asked earlier on is that why is it important to talk about what? Metabolism. The reason why we're talking about metabolism is what? It is because this is the liver, okay? The drug, so let's say this is a blood vessel like that. The drug is here, okay? The drug will come and enter there, okay? It's entering into the liver, then metabolism to this drug is going to happen. Okay, now let's say this drug is what? Let's use this one, L. L is what? Lipid soluble. It is lipid soluble. Okay, and the body doesn't like something that is lipid. Okay, if the body want to excrete that drug, so the drugs always are excreted in what? Water soluble. Okay, so if the liver sees to say, okay, this drug is lipid soluble and we need to excrete it, because if it is left accumulated, it's going to cause what? Problems. We are going to convert it into what? Something that is okay, which we can use it in a form that we can excrete. What is that form? Water soluble. So the liver is going to convert this lipid soluble drug into what? Water soluble drug. Let's just use the W or W. Water soluble what? Drug. Why is that happening? So that it can be what? Excreted. Okay. But excretion now, we'll come and talk about that, okay? Here, under excretion, so that it can be excreted. But the other main reason why, apart from excretion, why metabolism happens, the other reason apart from making it easy for elimination, what is the other concept? The other concept is what? To make it what? Active. Active or inactive. That is the other important what? Aspect. Okay, you need to know about that. Because, okay, we'll come and know more about the drug metabolism, but basically you need to know that the reason why metabolism happen is what? Because that drug has to be excreted, or it has to be activated or inactivated. Okay, so activated because there are some drugs that we give as what? In a form where it's not what? Activated. Then if it goes to the liver, it's going to be activated so that it can what? Start showing its effect to the body. Or maybe if you want what? To destroy the drug, the liver will start now getting those activated drugs to make them what? Inactivated. So those are the functions of the liver, or the organs that are undergoing that like metabolism to occur there. Then they are going to do what? They are going to make the drug active or inactive, or what else? They are going to promote what? Excretion. So what are we saying about metabolism? Okay, so what we are saying about metabolism is what? Drugs are what? Metabolized into what? Let's just say active or inactive what? Form, or make them what? Water soluble. For what? What did I say? For excretion or elimination, whatever. Okay, so that's what I talked about under what? This part, drug metabolization. We'll talk about the CYP450 enzymes, all those things. Okay, we'll come and talk about them. Okay, now let's go to this one, the last one, E. Okay, E is what? Excretion. E is what? Excretion. Now, what about excretion? What do you think? Drugs are what? Removed. Are what? Removed from the what? From the body. Okay, but there are two ways in which the drug can be removed from the body. Via the what? The kidney. Okay, via the kidneys. Okay, via the kidneys, or the other one is what? Via the what? Biliary tract system. Okay, this one. System. Okay, so if you want to excrete a drug, okay, it has to be what? It has to be maybe via the kidneys. Remember that the kidneys, they like to excrete drugs that are what? Water soluble. Same applies to the also biliary tract system as well. Also, you can excrete a drug from the body via the what? Biliary tract system. That's connected with what? Gastrointestinal tract, so that it can be removed via the what? The stools of feces. Okay, very important concept. So that's all about pharmacokinetics. This is just the overview. That's what we'll be talking about. If you know this overview, basically you are good to go. Okay, so that we can now come back and start talking about what is pharmacokinetics. Okay, what is pharmacodynamics? Okay, pharmacodynamics. Remember, so I'll give an illustration here. Okay, so we have a blood vessel here. Okay, and these are what cells within the interstitial space like that. Okay. Remember that if a drug comes like it is being distributed like that into this interstitial space, remember, okay, what's going to happen? So pharmacodynamics now talks about what this drug that has been distributed in the interstitial space and how it interacts with the cell to produce a specific effect. So what am I saying? So this drug that has been distributed here is going to interact with these cells, so that these cells can produce a desirable pharmacological effect. So that's all about pharmacodynamics. How a drug is going to interact with tissues. After interacting with it, then we expect effect, whether therapeutic effect or maybe a clinical desirable effect. We'll talk about that. Okay, that's all about pharmacodynamics. What are we saying? So what's a major point that we need to understand here? So pharmacodynamics just talks about drug interacting with what? Tissues of different organs. The more after interacting with tissues with that different from those different organs, what do we expect? We're expecting what effect? So drugs interacting with what tissues, producing what? Let's just put here producing what? Certain effect that we need to talk about. Okay, certain important things that we need to talk about. So a drug, if the drug interacts with the cells, how do they interact with cells? Remember that they are going to interact with cells by binding to specific receptors. We'll talk about pharmacodynamics, the different types of receptors, the ion-gated channel receptors. We'll talk about the G-coupled protein receptors, the kinase type of receptors, a lot of types of receptors that we'll talk about. Okay, so this is how they are going to interact with tissues. Now, there are some certain terms that we need to understand under pharmacodynamics. Okay, even I'm not going into details, don't worry. So there are some certain terms that we're going to be using. Okay, so we'll talk about what we call the difference between drug action and effect. So you need to know the difference between drug action and drug effect. Okay, what's that difference? Okay, drug action, basically we're talking about how the drug is going to interact with receptors, producing a response. So we're saying drug action is what? So let's say action. So we're talking about drug action. We're talking about how a drug is going to interact with a specific receptors on those tissues to produce a response. A response is the effect. Okay, what are we saying? We are saying drug action is what? Just basically interaction. We are saying interaction of a drug with a receptor. Okay, this is what we are saying, to produce what? To produce a response. From where? Where are we getting the response from? From what? Tissues or cells. So let's say from what? From tissues or cells. Okay, that is all about action. And action, how the drug is interacting so that it can produce a certain effect that we want. Is either the effect is going to be diminished, inhibited, or it's going to be stimulated. Okay, either we're going to talk about antagonists and the agonist type of drugs. Okay, under pharmacodynamics, don't worry. So now, what about effect? What about the effect? Because we're going to have a lot of things under effect. We've got side effect, okay, desirable effect, expected effect, a lot of effect. So what are those? So effect, we are going to say observable. Okay, so we're saying So observable what? Observable consequences, okay? After what? Drug action. So you need to take this, you need to know this difference, okay? Observable consequence after drug action. This drug that's going to drug action, remember that it's just an interaction, the way the drug is going to interact with the receptor, okay? Then that's what we call drug action, right? So that the drug can what can the cell can respond like that, okay? Now a response is what we call an effect, okay? Now that effect can be something good or something bad, okay? Then if we are talking about the response of cells, we are talking about what the effect, okay? The effect can either be bad or good, okay? Because we need, if you give a drug, we need maybe some therapeutic effect, okay? Also maybe we are expecting what, some side effect. So effect, basically what I mean is what is an observable consequence after what drug action. It's not a consequence, not something that is bad. It can either be good or bad, okay? Anything that's going to come up after what drug action is what we call what drug effect, okay? The last important point that you need to take note of, we also need to take note of what mechanism of action. Mechanism, so these are the terms that they like asking about: mechanism of action and what mode of action, okay? Mode of action of drugs and the mechanism of action of drugs. So these are the two important terms of drugs. So these are the important terms that they are going to be asked you, okay? So mechanism of action, okay? So what is the mechanism of action of a drug? So if they ask you to say state the mechanism of action of this penicillin drug, or maybe anything, maybe metoprolol. So those are different types of drugs. The moment they ask you what is the mechanism of action of this drug, what do they need? They need the what? Molecular action of that drug, okay? So what are we saying? If you talk about, so let me just say ME, then A, mechanism of action, okay? Mechanism of action, what do they expect you to do? You expect to talk about what? The molecular action of that drug, okay? How the drug is going to interact with a cell, and also some cellular transduction pathways, okay? What do I mean? If this is a drug, if this is a what? A cell like that, and this is a what? A receptor. So if they ask you to talk about the mechanism of action, they are asking you this. This is a drug. If it is it has interacted with that receptor, they are asking you to say what are the what intracellular pathways that are going to lead to what the effect. So these are molecular things that we talk about. Maybe if you talk about a good example, the G protein coupled receptors, you remember how the alpha subunit of that G protein there, it will go to what to activate the phospholipase there, and all those things, the production of what IP3, and also accumulation of what calcium ion, all those they are under what mechanism of action. We are talking about what the cellular what mechanism, okay? I mean the molecular mechanism, okay? That's about what the mechanism of action. So what are we saying? We're talking about, so if they ask you about the mechanism of action, what are you expected to talk about? We are talking about what you need to talk about what molecular what mechanisms. Okay, you need to know that. Okay, the mode of action, basically this is the mode of action. Yes, I say that mode of action, that is very simple. They are just talking about cellular action. Okay, cellular action and mechanism of cellular action and molecular action, these are two different things. Cellular action, basically they are just telling you to say, okay, tell us the let me give you an example to say, okay, if they ask you to say, okay, what is the mode of action of let me just give a good example of what norepinephrine. What's the mode of action of norepinephrine? We know that is a what sympathomimetic. Okay, that's a sympathomimetic drug. An agonist is in the sympathetic nervous system. Then they ask what's the mode of action of this. So if they ask you the mode of action, we are going to say, okay, it's going to interact with a certain receptor which we call maybe alpha receptors there on the blood vessels. Then it's going to promote what? Vasoconstriction. That's a mode of action. It's interacting with the receptors, and what's the response? vasoconstriction. Now, if they ask you to say what is the mechanism of action of epinephrine, don't say they interact with the receptor, then the result will be vasoconstriction. No, you need to go deeper. You need to talk about what the mechanism of action, like what. If now, if this epinephrine interacts with what this receptor, the G-coupled protein receptor, which is the alpha receptor there, you see it interacts. What's going to happen under biochemical level? What's going to happen? Then you talk about the G proteins. They are those molecular level type of mechanism, up to increase in the calcium level in the cell, leading to that cell to start contraction or contracting like that. Okay, leading to vasoconstriction. So basically, that's what I'm talking about. If you say mechanism of action. Then since we are done with just the overview, then what we expected is that if you come back, you come and talk about more about a lot of things, like those curves that you see, those I mean those effective, those type of graph, we'll come and talk about them. Okay, a lot about the different types of receptors, types of like the agonists and also antagonists, partial agonists, all those things we'll come and talk about under pharmacodynamics. And also same applies to pharmacokinetics. We have a different video for absorption, distribution, metabolism, and what? Excretion. Very, very important. Okay. So all the best. Make sure that you study more. Meet you more. All right.